Hello again everyone, this is the second video of traffic engineering. We're talking about traffic stream components and analysis, and we're going to start again with calculating the different kinds of average speeds on the road. So we have here two types of speeds. I'm going to repeat this again from the other video. So speed, let's give speed the word U, not the letter U, not the letter S. Again, we have different textbooks, S or U. I just don't want to confuse it with spacing here. Well, use distance divided by time, and we're going to use this in our traffic speed analysis. So we have here two types of speed. Let me show you the difference between them. When we talk here speed, we're talking here average traffic speed. We're talking here about speed of one vehicle. We're talking here about the average speed on the road. So the first one here is so simple. When you have here, for example, if you're like having a speed gun and you just measure the speed of, let's say, 20 vehicles, each one has its own speed, and you average them. So the speed for the timing speed is sigma ui divided by n. Different speeds that you have, you add them up and you divide by the number. So here in this case, S1 plus S2 plus S3 up to S20, and that's here the timing speed is equal to sigma S1 to S20 divided by 20 vehicles. That's what we call here timing speed. The space mean speed is a speed trap, but with probably a little bit longer distance. So all you do here is that you have a distance d, and you measure the timestamp of every car. So you measure here delta t1 for car number 1, delta, and then when I say delta, because this is t1, this line here, and this is t2, the difference is delta t. So for every car here you have different delta t's, so it's delta t1, delta t2, and so on, delta t's divided by your n. This gives you this the average speed, and this is how you do it. So you say here my distance, because distance divided by time, distance divided by time, and here the time here is sigma delta t's of different times. This gives me what we call here the space mean speed. They are very, very similar. There's no big difference between them. They could give a difference that's very, very small between them, but there is a small difference between them. So this is how we do it. The timing speed is the average speed for each car. So here this is distance divided by time of each car. So that's for specific car. Then you add them up for all cars and then divide by the number of cars. The space mean speed, here you have the distance divided by average times of every car when it passes through your speed trap from point 1 to point 2. When we do it in statistical or mathematic terms, you can write it this way. So it's this n, since the same n number of cars goes up here, so it's n times d divided by the summation of travel times for all cars. So n here is the number of vehicles, ti time it takes for this ith vehicle to travel across this section from here to here, and d is the distance traveled for your highway. So we have two types of speeds, TMS, time mean speed, or space mean speed. Let's show you the difference here. So let's say we have 6 vehicles, that's an example here, and your distance is the same. You may put your speed trap on a distance of 1,000 feet. Our speed traps are bigger because we're not here cups. We're just trying to figure out what is the average distance throughout your section of the highway. So we measured 1,000 feet, and using a camera we were able to timestamp every car from here to calculate the travel time t. I call it delta t or t, it doesn't matter. So the first car, it took 18 seconds to travel this 1,000, 20 seconds, 22, 19, 20, 20. And then we add them up as per statistical analysis. Here we have 119, and First way, when we calculate the TMS, we're just going to measure the speed of each vehicle. So this is the first vehicle, second vehicle, third vehicle, and then we add them up. We divide by the number of vehicles, which is 6. So this gives me the TMS, time mean speed. So it's 303.7 divided by 6, which is this number here, 50.6. Now let's do it now, the space mean speed, which is probably the most confusing one here. So when we put this equation here, we can use this one or that one. I prefer to use this one, which is easier. So it's ND, number of cars 6 times 1000. Here what you do here is the addition of the travel times for each one of them. So the travel time 100. If you want to do it the other way, which is more, you can understand it a bit more, my SMS is equal to D, and let's measure this one here. So how you do it, you create another one here, and you say here 18 divided by 6, 20 divided by 6, 22 divided by 6, and so on. You do it here per vehicle, or you just calculate here 119 divided by 6. In other words, you're calculating the average travel time for the 6 vehicles. So 119, so here divided by, so it's equal to 1000 divided by 119 over 6. This 6 will go up here exactly like you do here. So 6 times 1000 divided by 119. So you notice here the difference is 0.2 feet per second, which is not a big deal, but it shows you something, that usually the space mean speed is a little bit less than the time mean speed. And it's amazing that you can find the difference between the two speeds using the same type of data. And well, since we're talking statistics here, you're going to notice that the time mean speed is always bigger than the space mean speed. And this is the difference here. The difference is the standard deviation of your data, your data for travel time, divided by SMS. I'm not going to do examples of this, just show you that always SMS is less than TMS. That's all I want to reach here using your statistical analysis. Then comes density. And density here is, again, when we have a picture of the road. Let's look at this lane here. You count how many cars in this. Let's measure 1 kilometer or 1 mile. So it's the number of vehicles traveling over a unit length of the highway in an instant of time. So here we stop the time. Taking a picture is stopping the time. So 4 vehicles are distributed over a length of highway 15 feet long. Then what's the density? Usually the density is either kilometer or feet, or mile. So we do just our X analysis here. So 4 vehicles per 500 feet. Then what is the value for your whole mile, which is how much? 5 to 80 feet. Then you calculate here the 42 vehicle per mile. Sorry guys, it was my alarm clock. So here we have K, which is 42 vehicle per mile per lane, just based on this X or cross multiplication or simple analysis here. So K here, this number here tells me, okay, how congested you are. Another value we use a lot, remember when we talked about loop detectors? The loop detector gave me another occupancy. This is different than the vehicle occupancy. This is not vehicle occupancy. This is called traffic occupancy. It's how much time your vehicle has occupied this loop detector. So it's used for loop detectors. Remember this electromagnetic field? When the car goes in, the faster it goes, the faster it will leave this loop detector. So it gives me the percentage of time this loop detector will be occupied. And this gives me, this is so much related to density, meaning that also related to speed. The faster you go, the faster you go, then the less time you're gonna be occupying this magnetic field, and the less time meaning that you are less congested. So it's related also to the density. So this is occupancy, and occupancy here is in percentage. Percentage of time cars occupy this. The more cars occupy, and you get occupied more time in your hour, meaning that you have more density here. So your density, and I'm going to put this as K not D. Let me just make it less confusing. It's equal to 5 to 80 times this percentage of time, which we call O, divided by length of vehicle plus the length of your loop detector, which I gave you. So we have here two lengths, the length of vehicle and the length of loop detector. We add them all together. Remember guys, when we talk that we can transfer between different values and we have a relationship between the headway and the volume. Well, since headway is in second per vehicle and the flow rate is in vehicle per hour, and we have 3600 seconds in an hour, then you're going to notice that they are an inverse relationship. You can see this, they're inverse, and this is just how many seconds in an hour. In other words, when you inverse your headway and change it into an hour, it gives me the volume, and that's the relationship between headway. Remember then, what's the headway? It's the difference between the time where the front vehicle passes by you as the counter between every two consecutive vehicles. And by the way, the headway is used a lot when we design traffic signal to define the difference of time between every two consecutive cars passing through the signal stop line. We use this to define a lot in the signal, so it's a very important value here. So the headway is a difference between the time of front of vehicle arrives at the point of the highway and the time of front of the next vehicle arrives at the same point of the highway, this guy here. This guy, as he measures the headway, can also measure the volume just by counting cars per hour. So they are very, very related, and that is how you calculate this. Then we talked about spacing. Well, remember the spacing? It's the distance between the front of vehicle and the front of following vehicle. And the smaller the spacing is, the more congested you are, the more density you have. So spacing here is in feet per vehicle. But you remember when we talked about the density, K, it's in vehicle per mile. Notice that they have inverse relationship as well, inverse units as well, and we use lane. And always use lane here. So you notice here that from feet to mile I have 5 to 80, so it's just the inverse relationship. Okay guys? And this is how, these two equations here is how we transfer from macroscopic to microscopic. And also we can calculate average speed from H and S. Yes, we can do that. So putting the H and S divided by H and divide by 1.47 to put it in miles per hour, we can calculate the time mean speed. And I want you to think about this guys and tell me as part of your homework that you will submit, what is type of speed? Is it time mean speed or space mean speed, and why? And then we're going to talk here about the traffic flow theory, which are very simple equation. That will be the next presentation and for the next class next week. And by this guys, I end the traffic stream analysis. I want you guys to read chapter 5 or any textbook or any version of the textbook, and we will solve questions. And the main reason for this video is to define the different components of your highway when we talk about volume, when we talk about traffic flow, when we talk about density, headway, occupancy, spacing, speed. We have two speeds, time mean speed and space mean speed. And by this guys, I end my video. I apologize if there were any background noises that created issues, especially in the first video. And see you in class, guys, and have all a great day, and see you soon.